Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are fine. I am Mrs. Amina Sadiq, working as subject specialist in mathematics at Divisional Public School and College, Sahiwal. Dear students, today we are going to discuss about the cube roots of unity and their properties. Let's recall some previous concepts. So, what is the meaning of root? A root of a number, let's suppose the number is x, is another number y, which when multiplied by itself, a given number of times equals x. For example, the second root of 9 is 3. Because 3 when multiplied by 3 is 9. So 3 is the square root of 9. The second root is usually called the square root and the third root is usually called the cube root. So what is the meaning of root of a unity? A root of unity is basically a complex number that, when raised to a positive integral power, it results in 1. Like iota raised to power 4 is equal to 1. Iota is a complex number and 4 is a positive integral power and the result is 1. So, iota raised to power 4 is a root of unity. So how can we find the square roots and the cube roots of unity? Let's start with the square root of unity, which can be written as the radical sign with 1 as a radicand. Let the root be x. So x is equal to square root of 1. To remove the radical sign, we take the square on both sides and get x square is equal to 1. Taking 1 from right hand side to the left hand side, we get x square minus 1 equal to 0. This can be expanded by using the identity of squares. X square minus 1 is equal to x plus 1 and x minus 1, which is equal to 0. So these two are the linear factors, either x minus 1 is equal to 0 or x plus 1 is equal to 0. Solving them for the values of x, we get either x is equal to 1 or x is equal to minus 1. This means that the square root of 1 has two values, either it is equal to 1 or it is equal to minus 1. So it means that the square root of unity is 1 and minus 1. Now, for the cube root of unity. The cube root of unity can be written as the cube root with the radicand 1. Let x be the root of cube root of 1. To remove this cube root, we take the cube on both sides and get x cube is equal to 1. Taking this 1 from right hand side to the left hand side, we get x cube minus 1 is equal to 0. We can expand x cube minus 1 as x minus 1 into x square plus x plus 1 equal to 0. We get two factors, x minus 1 a linear factor and x square plus x plus 1 a quadratic factor. This expression tells us that either x minus 1 is equal to 0 or x square plus x plus 1 is equal to 0. Solving them for the values of x, we get x is equal to 1, or applying the quadratic formula, we get minus 1 plus minus square root of 1 square minus 4 times 1 over 2 times 1. Simplifying this, for the value of x, we get minus 1 plus minus iota under root 3 over 2. So we get two complex values and a real number 1. So the cube roots of unity are 1, minus 1 plus iota under root 3 over 2 or minus 1 minus iota under root 3 over 2. These two roots are the complex conjugates of each other and they are called the complex roots of cube root of unity. So we can define the cube root of unity as the number which when raised to the power of 3 gives the result as 1. Simply, the cube root of unity is the cube root of 1, that is, cube root of 1. Keeping this definition in mind, we can easily understand that the cube of 1 minus 1 plus iota under root 3 over 2 and minus 1 minus iota under root 3 over 2 is 1. We can justify it by using the calculator. As you can observe that minus 1 plus square root of minus 3 over 2 the whole cube is equal to 1 and minus 1 minus square root of minus 3 over 2 the whole cube is also equal to 1. So, these are the cube roots of unity. The two complex cube roots of unity are minus 1 plus iota under root 3 over 2 and minus 1 minus iota under root 3 over 2. If any one of them is called omega, then the other is called omega square. Omega is a Greek letter used to represent the cube roots of unity. Now it's the time to discuss the properties of cube roots of unity. The first property is we have to prove that each of the complex cube root of unity is the square of other. As we know that the two complex cube roots of unity are minus 1 plus iota under root 3 over 2 and minus 1 minus iota under root 3 over 2. And we have to prove that the square of minus 1 plus iota under root 3 over 2 is equal to minus 1 minus iota under root 3 over 2 and the square of minus 1 minus iota under root 3 over 2 is equal to minus 1 plus iota under root 3 over 2. Proving the first property, we consider the left hand side. Minus 1 plus iota under root 3 over 2 the whole square, when it is expanded, minus 1 plus iota under root 3 can be written as minus 1 square plus iota under root 3 the whole square minus 2 iota under root 3. This 2, when multiplied by 2 or when we take the square of this 2, we get 4. The numerator is obtained by applying the identity for squares, that is a minus b the whole square is equal to a square plus b square minus 2ab. Minus 1 square is equal to 1. Square root of 3 the whole square is equal to 3. The square and the square root cancel each other. Iota will become iota square. Minus 2 iota under root 3 will come as it is, divided by 4. Iota square is equal to minus 1, so we can write it as 1 plus 3 times minus 1 minus 2 iota under root 3 over 4. Simplifying this, we get 1 minus 3 minus 2 iota under root 3 over 4. Taking 2 as a common factor, we get 2 times minus 1 minus iota under root 3 over 4. After cancellation, we get minus 1 minus iota under root 3 over 2, which is the right hand side of the given equation. Similarly, for the second equation, when we have minus 1 minus iota under root 3 over 2 the whole square equal to minus 1 plus iota under root 3 over 2, we consider the left hand side, that is minus 1 minus iota under root 3 over 2 the whole square. Again, applying the identity for the squares, we get minus 1 square plus minus iota under root 3 the whole square plus 2 times iota under root 3. Solving it, we get 1 plus 3 times minus 1 plus 2 times iota under root 3 over 4. Again, solving it and simplifying it, we get minus 1 plus iota under root 3 over 2, which is the right hand side of the given equation. So, we have proved that the square of complex cube roots are equal to each other. Now we have to prove that the product of 3 cube roots of unity is 1. We know that the 3 cube roots of unity are 1 minus 1 plus iota under root 3 over 2 minus 1 minus iota under root 3 over 2. When multiplying these 3 roots, these are the complex conjugates of each other, so they can be written as minus 1 square minus iota under root 3 the whole square over 2 multiplied by 2 equals to 4. Solving this expression, minus 1 the whole square will be equal to 1. Iota under root 3 the whole square will be equal to minus 3 iota square over 4. Putting the value of iota square, we get minus 1, which multiplied with this minus will become positive 3. On solving, we get 4 by 4, which is equal to 1. So, the product of 3 cube roots of unity is equal to 1. Or we can write it as 1 times omega square is equal to 1, or omega cube is equal to 1. And the next property, we have to prove that each complex cube root of unity is the reciprocal of the other. As we know that omega cube is equal to 1, or we can write it as 1 times omega square is equal to 1, or simply omega multiplied by omega square is equal to 1. Moving this omega square from left hand side to the right hand side, we get omega is equal to 1 over omega square, or when we move omega from left hand side to the right hand side, we get omega square is equal to 1 over omega. Here I am solving omega is equal to 1 over omega square and leaving omega square equal to 1 over omega for you as practice exercise. So we have to prove that omega is equal to 1 over omega square. We know that if omega is equal to minus 1 plus iota under root 3 over 2, then omega square is equal to minus 1 minus iota square root of 3 over 2. Considering omega square, which is equal to minus 1 minus iota under root 3 over 2. Now we reciprocate it, we get 1 over omega square is equal to 2 over 1 minus iota under root 3. Since we know that when iota appears in the denominator, we rationalize it. So rationalizing this equation, we get 1 over omega square is equal to 2 over minus 1 minus iota under root 3 multiplied with minus 1 plus iota under root 3 over minus 1 plus iota under root 3. For rationalization, we consider the complex conjugate of the denominator and multiply and divide it by the same number. On solving, we get 2 times minus 1 plus iota under root 3 over minus 1 square minus iota under root 3 square. Simplifying it, we get 2 times minus 1 plus iota under root 3 over 1 minus 3 times iota square. Putting the value of iota square, we get 3 times minus 1. On solving this expression, we get 2 times minus 1 plus iota under root 3 over 1 plus 3, which is equal to 2 times minus 1 plus iota under root 3 over 4. Reducing this expression into the lowest form, we get 1 over omega square, which is equal to minus 1 plus iota under root 3 over 2, which is equal to omega. So 1 over omega square is equal to omega. So we have proved the first property, and second is left for you as an exercise. The next is, we have to prove that the sum of all the cube roots of unity is 0. We know that the cube roots of unity are 1, minus 1 plus iota under root 3 over 2 and minus 1 minus iota under root 3 over 2. If we call omega equal to minus 1 plus iota under root 3 over 2, then omega square is equal to minus 1 minus iota under root 3 over 2. So their sum should be equal to 1 plus omega square. Putting the values of omega and omega square, we get this expression. Simplifying this expression, we get by taking the LCM, we get 2 minus 1 plus iota under root 3 minus 1 minus iota under root 3 over 2. They all cancel each other because they are the additive inverses of each other. So we get 0 in the numerator divided by 2, which is equal to 0, because 0 divided by any number is equal to 0. So the sum of all the roots 1 plus omega square is equal to 0. From this property, we deduce some results, which are, since 1 plus omega square is equal to 0, so 1 plus omega is equal to minus omega square. Taking omega square from left hand side to the right hand side, we get this result. The second result is 1 plus omega square is equal to minus omega. For this result, we took omega from left hand side to the right hand side. For the third result, omega plus omega square is equal to minus 1. We took 1 from the left hand side to the right hand side. These three results helps us in solving many problems in a simple and easy way. The higher powers of omega can be reduced into smaller powers and can be solved by using these properties. For this purpose, we are considering some examples, like if we have omega raised to power 4, we can break it into omega cube and omega. Since omega cube is equal to 1, so we put the value of omega cube as 1, and this omega remains there. 1 times omega is equal to omega. So omega raised to power 4 can be reduced into omega. If we have omega raised to power 10, we can write it as omega raised to power 9 plus 1 or omega raised to power 3 the whole cube times omega. Since we know that omega cube is equal to 1, so 1 cube times omega is equal to omega. Similarly, if we have omega raised to power 23, we can write it as 21 plus 2. 21 can be written as omega cube the whole raised to power 7 times omega square. Omega cube is equal to 1, so 1 raised to power 7 times omega square, which is equal to omega square. These powers can be negative, so omega raised to power minus 5 can be written as omega raised to power minus 3 times omega raised to power minus 2. Omega raised to power minus 3 can be written as omega raised to power 3 the whole power minus 1. Omega raised to power 3 can be written as 1 and any power of 1 is 1. So 1 multiplying with omega raised to power minus 2 and omega raised to power minus 2 means 1 over omega square, which we have already studied, is equal to omega. So 1 times omega is omega. Let's recall the important points we have discussed in our today's lecture. The first thing we discussed was the cube roots of unity, which are defined as the numbers which when raised to the power of 3 gives the result 1. And the cube roots of unity are 1, minus 1 plus iota under root 3 over 2, minus 1 minus iota under root 3 over 2. If any one of these complex cube roots of unity are represented by omega, then the other is called omega square. The complex cube root of unity is the square of the other. The product of 3 cube roots of unity is 1. Each complex cube root of unity is the reciprocal of the other. And the last one is the sum of all the cube roots of unity is 0. That's all from our today's lecture. I hope you understand our today's topic. Please listen the video very carefully, and if you have any problems related to this lesson, you can ask your relevant teachers. Stay safe, stay at home, take care of yourself. Thank you and Allah Hafiz.